Hello, all. Depending on where you are, good morning, good afternoon, and good evening. Today, we're going to share some of our experience in embedding SRE principles in data platform within PayPal, where we were, where we are today, and our future, and some of the lessons learned. I am Rajesh Ramachandran, product manager for big data platform engineering. Along with me, I have Selvaraj, who is an engineering manager in the same team. As organizations start collecting a large amount of data sets about their customers and their behaviors, to get value out of these data sets, one has to dice it, model it, and analyze it. And PayPal is no different in this. We also do a lot of data analysis to derive value for our customers and our business entities. To accomplish this, data engineers within our organization play a pivotal role. They constantly move, transform, and model data sets to derive that value. To enable these thousands of data engineers within our organization to take their products to market faster, we have to provide a very reliable and scalable data platform for them. If you take the PayPal data landscape, we are talking about data at scale. PayPal has petabytes of data today, and it is constantly growing as our businesses continue to grow and we have more acquisitions within our organization. So there is a large amount of data sets that are moved across our data platforms on constant basis, either in batch mode or in streaming mode. And we are talking about terabytes and terabytes of data that are getting moved on a daily basis. Approximately, we have around 500K batch executions per month. And we have more than 2,000 data engineers across our organizations who constantly play with this data either to transform, model it, and dice it. If you take the PayPal data platform, you can actually, that supports different business needs, you can actually have multiple, different types of data sets. The first being the transactional data set, which is basically the data coming directly from the customer into our databases, which is our Oracle data set. From there, the data gets moved into more of an application data set, which is in terms of Aerospike or Juno or some other MySQL, NoSQL, there are MongoDB, there are multiple data sets that we have today. And then there is the analytical data set, which is where the lot of transformation, data dicing, modeling happens today. Today, predominantly, we use Teradata and Hadoop as our analytical data store. So if you see on a daily basis, data gets moved, transformed across all these data platforms in large amounts. To enable this data journey, we introduced the concept of data DevOps within our organization. Back in 2017, if you see, there are a lot of manual deployments that were happening. So code, whether it could be a SQL query or your Teradata query or your Spark application, those were basically taken from your local file and then deployed into production. And back in 2018, what we did was to improve the data to go to production faster, take the products to market faster. We introduced the concept of self-service, where we did automated release management, and we also introduced a lot of auditing capabilities. In 2019, what we call them as enforced standard rails was introduced into our data DevOps product. So any deployment that is coming into the data world has to be coming from a GitHub location with a peer review approval, and lot of coding standards and platform standards were applied. So basically, we parse your code, whether it is a DDL or a DML or a Hive SQL or a Java code or a Python code, and apply some basic standards that we have governed, and before the code goes to the production. If those standards are not met, then we will push back the code to the developer to make those changes before it gets again redeployed into production. This year, our focus have been to increase our reliability, right? So what we trying to do today is introducing the concept of application governance. When you talk about application, generally it comes into your mind of web application or services application. The concept of application generally doesn't exist in the data world. But what we have done is introduce the concept of application. Application within the data world means moving the data from one platform to another platform, transforming it, manipulating it, and getting a business value out of it. The entire workflow is encompassed into an application concept. And today, any application within PayPal has to be governed, approved before that application goes into production. And we also introduced that any application that goes into production has to go through a testing process, a QA process, either in a QA stage or pre-prod environment with sample or real production data sets before you take it to production. And any change management that goes into production has to be approved, reviewed by somebody. And I also talk about a little bit on where we are going to go to future. If you take the entire part of this governance and reliability and scalability of our data platform, governance is part of it core. Unless you don't have proper governance checks and balances, your platform reliability is always questionable, right? So the immediate thought process when you talk about governance is, hey, is this going to add a lot of friction? Is it going to take a lot of time for us to take the product to market, right? Are we going to have too many approval processes? Actually, it is the other way around, right? If you have proper governance, then you will have a very scalable, trustworthy, and a data that can be protected and valuable, and you can trust that. For this to happen, we introduced the concept of application lifecycle management within the data platform, which enforces the governance through standard rails, proper validations, and access control across all data applications within PayPal. So we introduced the 3 lines of defense. The first line of defense is at the raw data level, where profiling, masking, and classification happens. At the second line of defense, we will introduce the concept of understanding the data, which is the metadata, where the data is coming from, who is moving the data, which batch is moving the data, the lineage, and what is this data set, right? The cataloging of the data and mapping of it. And the third line of defense is for the consumers. When they search the catalog, who's using the data, who's manipulating the data, who's changing the data. All these things applied at the consumption level. With this introduction, I would like to hand over this to Selvaraj, who is going to talk a little more about the application lifecycle management technical implementation. Go ahead, Karthik.
Thank you, Rajesh. Greeting technologists. Are you ready to dive into the details of data platforms? Let's get started. We're going to first begin by laying out the core foundational thoughts behind data in SRE. First, consider data to be the center of the operating process. The design, thought, and implementation should be always around data. Second, we always would have spent a vast amount of time writing and dealing with application code. Do not cram the same process or solution that you had for your application into the data solution. Third, design the data lifecycle in equal importance with the application lifecycle. They are tangential to each other in most ways. Finally, unify both the processes, application and data, through a common platform. We're going to look into the technical aspects of how we built a unique solution for data that includes events in SRE into a single platform. In the first section, we will look at our architecture evolution over the period. We begin our journey by writing POC in all segments, moved into the analysis of development and operational tools that was required to be part of the app platform for it to be holistic. We then built a MVC that offered solution isolating it by technology and business operations. The eventual state is moving into a microservice model with client-side UI composition. It had a beautiful service orchestration around the APIs that were exposed as part of the different applications. Going a little bit into the technical aspects, our deployment strategy is blue-green. We decoupled our brownfield application, which was in the monolith state using subdomain decomposition, and then finally evolved the user interactions by bringing in an UI side client composition. The middleware uses a mediator pattern. Also, in line with what we offer to our customers, the internal architecture uses a mix of SQL and NoSQL databases, both for handling application data as well as customer data. We also have the concept of relay servers. The relay servers handle the interzone network communication using a channel that can be monitored for all transactions. We can also process transactions in batch as well as stream modes. What you're seeing now is a high-level component architecture representation, our key stakeholders, and our fundamental technologies, how they interact with each other, and how the whole layout of the LAN looks like. As you will notice in the service area, there are 6 pillars that are very active now, and a couple more that are in the development phase. We will move forward to discuss the implementations that are done for each of these services and what considerations that we took for them at each of the stages. It starts from identification and moves all the way to maturity. In the identification phase, we talk about onboarding, requirements, and allocation. We pick the tools and technology that fit into the overall cycle and the operating ecosystem. The world of data operates around stateful situations, and point-in-time data is a very critical and integral aspect. Continuous integration and deployment perspectives need to have an alignment with data and its needs in line with business. When we move on, the next stage is about ideation, designing, and scheduling. When you have an application that needs to be designed, it should cover all the business and the operational aspects in an iteratable fashion, the agile way of it. We start by collecting the metadata of applications with the hardware performance allocations required with the business statements. Stakeholders who are using our product should be able to design, schedule the application in both batch and stream modes. Once you have designed the application, you move on to testing the application for sanity and its adherence to recommendations from architects and subject matter experts. Auditing, and very important aspect, which resolves around the compliance parameters. Auditing is not just internal. PayPal being an organization which is being continuously audited by the government agencies, internal auditors, as well as external auditors, need to be cognizant of the fact that every process that goes through can be auditable and monitorable. Security standards that need to be enforced should also be in parallel with all the process lines that we have developed. Before we go live, we start by profiling the applications through various factors. There are 6 major categories that we bring our application profiling into. 1, nature of change. 2, standards. 3, code. 4, review. 5, process. 6, design. Each of these 6 pillars have a unique set of constraints, starting with identifying what the nature of change could be. Is it a new requirement, or is it a iteratable business requirement? Is it a bug fix, or is it an ad hoc production change that needs to go into production? We also look at static and dynamic elements of the code. We look at some of the architectural standards that were enforced by our architects as well as our SRE professionals. And finally, the design constraints of the users' application themselves. Is the application restartable? Is the application resilient? Is the application being able to be managed when it comes to a third party? We factor in all these checks into the application before it goes into the stage of deployment. When it comes to the stage of deployment, data loading and verifications are another very important category of stages. Once active in production, the final stages of monitoring, management, and reporting come in to complete the cycle of the development. Let us look into some of the key challenges that included handling the big legacy stack that was part of data's whole ecosystem. It had a huge tribal knowledge that was built on top of it. It had a mix of both proprietary and open source solutions with no common grounds for development. We had to pick and choose products from markets to build the middleware layer. It included a lot of publisher subscriber model tools and tools that could handle the entire application folds with recoverability. There was no one ready-made product solution that was available, which we can pick out of the market that will solve all our needs for data. Though there were several challenges that we realized or had when we had this data stack built, we were able to successfully build a unique data platform and carried a lot of learnings along the way. We realized that everything, though proprietary or open source, can be automated. Security plays a very important part. If you do not consider it upfront, you will end up re-architecting and building your application in a very hard way. Ownership, a very fundamental factor that needs to be established at the start of the ecosystem. Ownership needs to be analyzed and evaluated through all phases and components. And finally, after profiling the behavior, we need to measure every single activity in the system in the most granular form. I hope all these challenges and learning will allow you to build a very constructive approach towards data platforms. Thank you so much. And back to you, Rajesh, for discussing the future and outcomes of our solution.
Thanks, Karthik, for the technical overview on the application lifecycle management and its architecture. Before we end the conversation, I like to talk a minute about what is the outcome of the changes that we have done so far and our future, where we are going with it. Today, because of the application lifecycle management and the governance, what we have achieved is there is a clear ownership of who owns the data, who owns the processes within the data, who owns the transformation, who owns the batches, who owns the streaming, so that there is a clear definition of responsibility and accountability, which is increasing the governance and the reliability of the data platform. Our data platforms are much more reliable, reducing the cost of our data operations, because our failure rates in our data platforms have gone down significantly. And now we have a much more efficient and scalable platform. Where we are going with this in the future is, today we don't have a very complete lineage of the processes of the batches and streaming. So it is very difficult to identify the root cause of a problem. When a batch fails, when a job fails, when a data have a corruption, it is very difficult to go around the chain, up the chain, to find out the root cause. So a complete lineage is a critical aspect to reduce the errors and failures in production. The second is to catalog all the metadata across the data platform, so that to reduce the duplication of creation of the same data set, the same transformation again and again, code duplication, data duplication can be reduced so that our platform becomes much more efficient and scalable. The last but not the least is we wanted to have a very scalable platform, which means that we are looking at moving most of our analytical platform into cloud, which will enable us to scale up much efficiently, as well as use some of the cloud best practices and services to scale it. With that, I like to thank the SREcon conversation and the entire SREcon team for selecting our discussion and giving us, both Karthik and myself, an opportunity to share our learnings and lessons. Thanks again.